Next, we're going to talk about increasing and decreasing functions. An increasing function is, at least intuitively, is a function that slopes upward toward the right, like the one you see on the left, and a decreasing function is one that slopes downward toward the right, like you see in the middle. Formally, the way we would define this is what you can see through these definitions here. So a function is increasing on the interval AB if for all points x1 and x2 in that interval, we can say that if x2 is greater than x1, in other words, if x2 is to the right of x1, then we would expect that f of x2 would be greater than f of x1. That's the formal algebraic definition of an increasing function. By the way, I know that some of you have taken a calculus course and you may have learned about increasing and decreasing through derivatives. What I want you to realize is that that's a theorem. This is the algebraic definition of an increasing and decreasing function, and what you learned about in derivatives is a way to detect whether this algebraic definition is true. If you did not take a calculus course, which is perfectly okay at this point, and you don't understand what I said, you can just ignore it. That was just a message for those who have taken calculus. The use of derivatives comes later, and that's a theorem that's on top of what we're talking about here. So anyway, we'll go to the decreasing function. What we can see is that if I write in x1 and x2, we get the opposite result. In other words, we see here that this is f of x1 and this is f of x2, and we can see that f of x2 is in fact less than f of x1 in the case of a decreasing function. It's important to note that a function is not so much increasing or decreasing in general, but rather is increasing or decreasing on a particular interval. So if we look at the function, if we look at the graph on the right, if I put in some numbers, such as, let's call that -1, and let's call this 2, what we can see is that the function is increasing from 2 all the way up to the right. It's increasing from all the way on the left up to -1, and it's decreasing in the middle. So what we would say is that this function is increasing on the interval -infinity, comma, -1. I'm going to put in a round bracket there, but I'll explain that in a minute. And then it's increasing also on the intervals to infinity, and it's decreasing on the interval -1, 2. Now I should point one thing out, though. I had said I'd mention something about the brackets. Strictly speaking, it would be correct to say that it's increasing on -infinity, comma, -1, hard bracket like that, and to infinity, and then that it's decreasing on the intervals on the interval -1 to 2 with hard brackets. The reason is that technically, if I look at this definition, I can satisfy this definition for a slightly larger interval that includes the endpoints. You'll often see that we really only talk about increasing and decreasing on open intervals. That's often the way textbooks do this, although in a very strict sense it's not correct. It's certainly correct to say that if I include in this interval here from -infinity up to -1, if I include the point -1, I can still satisfy the definition of increasing, even if I allow for the possibility that x2 could be -1 itself, rather than just a point directly to the, as close as possible to the left of it. So you can write the answer either way in that case. You can write it either the way I've written it in the box, which is more common, even though I think the way up here is technically more correct. So just to do a quick example here of evaluating a function for its increasing or decreasing properties. So let's ask whether the function f of x equals the square root of x is increasing or decreasing on the interval 0 to infinity. So let's simply suppose that, it's not a good color for that, let's just suppose that x2 is greater than x1. We don't know what these points are, but let's just assume that's true. So we'll assume this. Now let's just ask, is the square root of x2 greater than the square root of x1 for all x2, sorry, I'll write it this way, for all x1 and x2 such that x2 is greater than x1? It's a big question just to give the simple answer yes. You should all know enough algebra to realize that the square root of a larger number is in fact greater than the square root of a smaller number. So yes, we would say that f of x equals root x is increasing on the interval 0 to infinity. And of course, we don't have to worry about anything outside that interval since the function f, square root of x is undefined for negative numbers anyway.